All right, let's get started. Hello, everyone. Welcome to this month's community update. Real quick admin-y thing. I saw the viewer count drop when I first went live. I'm still getting used to this whole YouTube thing, so let me know if something weird happened and I need to be starting it earlier. But outside of that, welcome to everyone. Very glad you're here today. By all means, come say hi in chat. For those of you who are new, my name is Jason Dobies. I am a developer advocate at Google working on Bazel. I've been doing these streams now for a couple months. We're going to have a bunch of interesting topics coming up after the BazelCon submissions. There were a lot of really cool ideas that didn't quite make it into the conference, and a bunch of volunteers who want to come give that content on this community update. We're also going to have, at the end of the year in December, we're going to talk to PM and engineering at Google and just kind of do a year in review. So actually nice to know that I have a schedule coming up. It's nice to see things starting to fall into place. And you get to all that from the Bazel site. Real quick announcements before I get out of your way. By all means, please say hi in chat. It started off a little bit lively. Always like to see names, especially since I will be meeting a bunch of you for the first time in a couple of weeks. So it's very cool relating them. I'm seeing some speaker names on here and everything. With that, my last push for BazelCon of 2022. By the next time we meet, it'll be over. Thank God, because it's getting exhausting at this point. So a real quick summary of everything going on there. You can get to everything you need to know from this conf.bazel.build, and that will link you to the registration site, to the agenda, things like that. And let me do a quick summary because I've been talking about it and giving announcements and things like that, but haven't really taken too much time to dig into the conference. Those of you watching on recording after the fact, sorry, just fast forward 30 seconds and you'll get the good content. So it kind of expanded. The week now starts on Tuesday with the community day that is run by, wow, I feel super bad because I can't remember all of the names off the top of my head, so I don't want to say any of them and the risk of missing one. So it is run by the community, which is really, really cool. Coming from a really strong open source background myself, I love seeing the community be like, hey, we want to do something, and not asking Google for permission, but just being like, cool, we're going to do it. So you can find the link to registration on that on the same site as the BazelCon registration itself. It starts a little bit later in the day, around 11, and then that goes up until a happy hour. Again, thank you to all our sponsors. I apologize. I'm so frazzled for this update today. I don't have a survey set up or anything like that. I forgot to take notes on those kind of announcements. But thank you to everyone sponsoring that and everyone involved. You'll see all that information. So looking forward to seeing people on Tuesday. Spots are filling up for that, but there are still a few openings. And that'll be in person in New York. Off the top of my head, the name eludes me. Then we get to the event itself on the Wednesday and Thursday, so the 16th and 17th. There are still open registrations for that. It's a hybrid event. I don't think I've said that out loud on this channel before, but if you're unable to make it to New York, you're absolutely welcome to come watch it virtually. It's free in both cases. And you can find the links to those on this conf.bazel build as well. Keep in mind that the YouTube streaming is going to be on the Google open source channel, not this specific channel, although I will eventually get the recordings over to here. Realistically, I think everyone who registers virtually is just going to use the platform and watch it live at the time. And then there's a happy hour happening on the first night of the conference on the Wednesday. Information on that as well on the site. I believe it's got a separate registration, but I don't believe it's limited. But definitely take a look at that. Get your name down if you want to come. Have the happy hour and then kind of unwind after the sheer amount of content we have set up for the first day. Both of them got really, really dense. Enough about BazelCon. Well, okay, not exactly enough. So we will not be having a community update next month. I could have potentially squeezed one in, but I think I'm going to be pretty burnt after BazelCon. We'll pick up again in December and talk about the year in review, and then we will really start things up again in January and see what kind of new stuff I can get moving for then. Again, thank you to everyone saying hello in chat. I really, one of the things I would love to see out of this is a lot more conversation going in there. It's hard because you're paying attention and you want to be respectful of the speakers until you get the people that I love to joke around with, and then it's all bets are off. But by all means, say hi. It's great to get a chance to talk to everyone. But you're also not here to see me. So what I'm going to do is get our Hang on, there we go. Start bringing our speakers up to introduce themselves. So we'll start with Nikhil.
Hi guys, my name is Nikhil. I'm an engineer at Intuitive Surgicals. We are like a surgical robotics company, and kind of like working with Tweag. I think you'll see Guillaume next on like making a transition from like a CMake make build system to like Bazel. So Guillaume, on to you.
Hello everyone, so I'm Guillaume Maudoux. I work at Tweag, a consulting company, and more specifically in the scalable build system group. So I joined Intuitive to help them and work with them on the migration of the build system to Bazel. Anything else I should say? No? Let's go.
No, it's entirely up to you. Just get moving.
So this slide basically repeats the same information, but you have a nice picture of me. So what about the Intuitive itself? It's a company that makes surgical robots. And you see like the most impressive robot is on the left side. That's the one that does the surgery on the patient. And then you have like two more devices, one remote control console for surgeon, and then some vision card, like they call it. So it's a device that's inside of the surgery room and that can help monitor what's happening, control the robot for assistance next to it. Is that about right, Nikhil?
Yeah, yeah, mostly right. Like where you have the patient card which does the surgery, like Guillaume said. The surgeon console is where the surgeon is capable of like performing the surgery. The vision card is mostly for the assistants who are inside the surgical room to like monitor it and like also provide feedback to the surgeon, also communicate with the surgeon, and yeah, things like that.
Okay, and the whole point of all of that machinery is like to be minimally invasive, so the robot can operate during like very small cuts through the skin and go right to the place where surgery needs to happen. You don't need to come with hands, eyes, and like all of the surgeon accessing the patient. So this work is about migrating the legacy CMake build system to Bazel. It's still an ongoing work with a team that's growing slowly. It's like it started with 3 engineers and now there are 7 full-time people in the team. It started more than a year ago and it's not done yet. It's a very strange time in the process because we are like reaching some objectives, but not all of them. So you will share with us all the stress and all the nice things that can, well, everything that happens when we are ongoing migration. Yeah, that doesn't work. Why is it not working? That's even more strange. Yeah, that's better. Okay, sorry about that. Don't know what happened. So initial goals for the CMake to Bazel migration were to add sandboxing to the build, reproducibility, improve all of these like good and well-known features of build system that CMake does not provide always. Also, maintainability was a very important point because CMake experts are hard to find sometimes. And also because when the CMake build gets big and old and so complex, it gets very difficult to understand and to fix or to adapt to the new change required. And obviously speed was kind of like target too. We want builds to go faster because currently CI takes 4 hours, but it's not that simple. At least speed should like come as a free benefit because Bazel provides remote execution as proper reproducibility, so you can skip most things, and then as local and remote caches, all of that should bring lots of benefits. So there is some data about the Intuitive code base, tons of source files, tons of lines of codes, because if you like take into account all of the vendor sources with patches themselves, that makes for and large doesn't really make sense here, like very large projects. What this build system produce are built, well, obviously build artifacts, but these are like application and system images that we flash on the robot on the different boards. So that's a bit different from like a single application that you build to deploy on a laptop. Here you get a full system image. So we'll discuss the implication of that. It's mostly a C++ code base with also lots of Python, and then lots of small chunks of other tools like MATLAB, Bash, CUDA, Golang, lots of helpers written in different languages. So about the current build system, it's slow, but it's also like large. There are like 150 build nodes, and these are no small nodes, right? These are like huge machines that can run like extensive tests and emulate the robots in many ways. And there are 120 CI runs per day, meaning that, these numbers being so close, I know it's a bit strange, but if you take into account that one CI run takes 8 nodes in parallel to compile, then it explains why these two numbers are so close. You can like 8 parallel nodes for 4 hours amounts for about like the whole of a day. So it's the same number of builders than CI runs. That's also an expensive setup, because just try to imagine the price of all of these machines. Just to give some more numbers, but that's what we have right now in Bazel. We have like 350,000 actions and counting. And the build takes 1 terabyte of local disk for all of the different things we need to download and cache. So it's like, that's for a full build. We hope that no one really needs to do a full build on his own machine, but it's still a huge endeavor. One main feature of the build is that it's not granular, and that's like nothing to do with CMake or Bazel itself. Could be implemented differently, but the way the build is right now is that we build some C++ files, then these get bundled into applications, and then these applications produce application image, as they're called, but you can see like it's a system image that gets flashed onto a board, and that represents a huge file with all of the rootfs, all of the dependencies, everything that the board needs to function. So think of it as a complete Linux system. It's not always Linux, of course, but that's the right idea. So build artifacts themselves are like just large chunks. They are not just small files that you can shuffle around. So when you have one such file and you need to copy it over the network, it takes time. And then the action themselves, mostly tests, are also like monolithic. Integration tests, for example, need to run inside an emulator. And that's a lot of Docker images running in parallel and talking to each other, emulating each of the components of the robots. And these tests take about 1 hour. And there is like no way to split that easily, because you need to take into account the time to set up the emulator. So if you split it in 2, then you need to set up the emulator twice, and then you compute more, of course. Regression tests are also like one chunk right now that lasts for 2 hours, and user interface tests, like these are the 3 main tests that we need to run. And for now, they are still just one chunk. So about the robots proper, I discovered all of that joining Intuitive, but it's just crazy the number of different platforms, the tools that you need to just make one robot like that function. So like you have like peaks, like very dumb devices, and then more advanced boards, embedded boards like NVIDIA. You have microblaze Xilinx stuff. I won't cover the details of these, but that's a whole set of platforms and technical chip details that we need to take into account when we target these platforms. The build at Intuitive is a bit uncommon in the sense that we have lots of target platforms, but we have only one host platform. Everything builds on Linux and is cross-compiled for the target machine. So it means that, for example, the toolchain resolution in Bazel is like overkill for us because we know beforehand what toolchain we want. And then the toolchain resolution system works, but not really needed. Having one host platform for the build makes it fairly easy to run in CI and everywhere else. That also means we don't really need remote execution urgently because CI works, right? Just take any Linux machine and you can build all of the tree. Of course, it doesn't work for tests, but tests, as I said before, are emulated, so that's also fine. Just like the emulators run on Linux, still we keep this simple property of a single host platform. And then, yeah, all of the different configurations, all different boards, versions, model, and like toolchain versions, all of these aspects make it for like a number of configuration that explodes. That's one of the issues we have to tackle with this build. Situation can be even more worse than that because, well, images that we flash on boards, so on chips in the robots, these images bundle a set of applications that they need. And then applications are made of like different libraries and may use like other applications. But if you take into account that each board has a different platform, then you understand that you need to build, for example, the network application for all of these three platforms. So it's not like you cannot map each source tree to a result build. We use transitions to have like the same code built for different targets and so built in different contexts. That's, I think, fairly uncommon for Bazel right now. And yeah, okay, it gets even worse than that because you have like loops in the dependencies. Well, not technical loops, but some applications depend on the other application, and you need to configure. We configure dependencies at each step, so we can end up with an incredible and exponential number of configurations for the same applications and libraries.
Let me jump into the question, mostly because I'm super curious about it myself. You should see on the screen, but if you don't have it up on your monitor right now, do you use the same machines for local development and CI, and do you use any remote caching?
Yeah, I can answer that, right? We do use the same things. The local machines are more powerful than the CI ones because we have like Threadrippers locally, and we do use like remote caching for Bazel at least now. Yeah.
Awesome, thank you. Roddick, if you have any follow-up questions, let me know. Otherwise, back to you.
Right, so it doesn't work, works. One of the questions we had initially, just like, I mean, I'm following this informal format, right? Like one question we had, and we don't have a clear answer yet, like how to encode all of the different configurations, because we can use basically constraints or flags, and like we tried both, and there is no clear-cut advantage for one or the other. Constraints like bind to toolchains easily, and you can select things correctly with that, but then you can create lots of different combinations that don't make sense. So if you have a constraint that like speaks about the Linux kernel version, then it doesn't apply to Windows. I mean, this is just a like stupid example that does not apply to Intuitive, of course. But we have that kind of issue. If you have something that speaks about like a peak machine, then that constraint has nothing to do with the rest of the build, and yet they kind of all live in the same namespace and can be used in different configurations. So it's a mix and match of different stuff that's sometimes difficult to navigate. With flags, well, flags have a clear advantage. They are easy to specify on the command line. So you can change a flag, you can build for different sets, for different configuration easily. That's less the case with constraints. And of course, constraints and flags do not integrate that well. So it's sometimes better to stick with one system. what we did is like use everything as platform, like as constraints, and so as platform constraints. So we encode a lot of information in these constraints, like way too much information. And we rely on the fact that we don't use all of the design points, that we don't use all of the combinations. So we can try to stick to a limited number of configurations that represent all of the different boards we have. It's still, as I say, difficult to select the right configuration on the command line. So if you want to build some application for particular targets or particular boards, then you would have to, well, we don't really know how to do that. Our best idea right now is like to generate a Bazel RC file that contains a lot of aliases so that you can just say config equals some board ID, and then you need a board ID for each different system. And that allows to pass all of the target platforms and other flags that are needed to set the proper constraints for the build. That's still not perfect. I would like to make a quick, but you see that the slide is full, a quick note about third-party dependencies and toolchains, because obviously when you cross-compile to a lot of different machines, you have a lot of different toolchains. Each target basically has its custom toolchain. That's the way GCC works, and most of the embedded world works nowadays. So you can usually download some binary toolchains, and you need to use that one to build for the given proprietary boards that you are using. That's lots of version of GCC, of course, but then we have even worse things like Linaro, that's a version of GCC, that's 6 gigabytes, but MATLAB, that's 10 gigabytes, and we need it. Vivado, which is a programming environment for chips, that's 90 gigabytes. This is getting really difficult to handle. We don't want that inside the source tree, of course. We don't really want Bazel to be in charge of that. Because that's like going to end into the remote caches, and we have a limited space there, so we don't want to evict or build results based on like huge blobs that are not supposed to change often. And yeah, then you have like other vendor dependencies, like just Qt, for example. It's kind of difficult we don't really want to vendor like to add the source code under Bazel supervision. We prefer to keep that as an external dependency library. So we decided to go for Nix, which offers kind of the same guarantees as Bazel on the package level. Using Nix, we can make our builds for the main source tree, just focus on the source tree files, and everything else comes as a bundle that Nix handles. Nix and Bazel integration is okay. It works well enough in practice. Nix is also reproducible. You have nice advantages, like it doesn't conflict with each other. So you can install different toolchains and they are not going to work together in any way. It lives outside Bazel, and it has also a very nice advantage. You don't have to create one sandbox, like one Docker sandbox that would be, according to my estimations, like 300 gigabytes. And then any change to any dependency for the whole build would need to recompile or to regenerate that Docker sandbox. That would be amazing. So Nix brings some granularity to the build environment and with all of the good guarantees that we need. That doesn't mean that Nix is perfect for that job, because cross-compilation, I mean, is available, but it's not everything is packaged correctly, so we need to do it. And it makes remote execution more complex, but that's we will discuss later.
Before we move on from Nix, actually, 2 questions on it. Is Nix like a package manager for third-party libraries?
I mean, I see it as a package manager where Bazel is a file manager. These are kind of different levels, right? Nix is managing the system. So whenever Bazel used to go to the system to find like GCC or to find system libraries or to find tools like Witch or whatever tool you use, we encapsulate Bazel inside Nix, and so Bazel finds Nix, and so we kind of fix the hermeticity holes in Bazel using Nix. Well, kind of reintroduce holes in Bazel, and because we know that Nix is there to has our back afterwards.
I like that. We introduced holes in Bazel so that we can fix them. Very cool. And the other question actually got answered accidentally, so you can keep going.
Okay, right. Sorry. So this is the interesting part. I think you need to keep in mind that it's still a work in progress, but we took lots of time to extract graphs of CI performance. So just to be clear about what's happening, Bazel, we use like the Bazel builds. Bazel, we use Bazel on the machine, right? And then it has access to the local disk cache and then a remote cache service. So we have like these two layers of caching, so that there is like local access that is fast and remote cache that is obviously slower. And as you know, we have like large artifacts, so it makes sense to keep both caches. CMake is a bit different. Well, you run CMake, it runs Ninja, Python behind the scene, and then everything ends up hitting C cache. And C cache is like only the local cache for all of these builds. One other thing you need to know is that currently the CMake CI is way more complete. It runs like 8 pipelines in parallel. Each of these pipelines builds the subset of the tree that they need, which is amounts to most of the tree anyway, but sometimes it's a reduced set. And then they proceed to do either the integration test or the UI test or the regression test, as we have seen, because each of them are just huge testing. So to reduce the overall build time, the build is split. Build happens in parallel on all of the threads. So they are basically doing the same job over and over again in parallel, because there is no like remote caching on these jobs. There is only the local C cache. So we have 8 threads compiling the same codes in order to have like access to all of the artifacts as fast as possible for them to run the tests. The Bazel CI is faster, or is simpler for now because it only runs the integration tests. And yeah, so it's kind of difficult to compare what's happening on these two set of machines, but we made our best, and I think this graph is quite an achievement in itself. So we see that the old CI, the CMake CI, has kind of no build that can finish before 40 minutes. And that's due to the structure of the build. So CMake runs, and that's kind of Ninja runs. It needs to run all of the actions because the build starts from scratch. And all of the actions are Ccache, wrapping GCC invocation. And Ccache, in the best case, will find it in the local Ccache. It's in its local cache. But all of that process, when there is nothing to compile and everything gets substituted from the cache, takes about 40 minutes. And then the build can be, some builds are obviously slower because they need to compile more. That just depends on the size of the change that we commit and that the PR is testing right now. Bazel, with all the work we have done, is better from that graph because many builds can finish within 5 minutes. Well, that first bar is like below 5 minutes. The second one is below 10. And so it's really, really nice to see that. But then there is the other side of the graph. And with Bazel, we have incredibly slow builds happening from time to time. And each of these are really difficult to debug. You would think that it's like a single culprit that, you fix the issue and then that's it. But it turns out that for each of them, we find different issues. We find different problems. Sometimes it's the network, sometimes Bazel rebuilding something we didn't intend to, but like Bazel is very picky. Sometimes there is a bug, sometimes there is, I can't really just list all of the things we've encountered. And this is kind of what we achieved with all of our changes. You see that there is one build that took like more than 5 hours. And this is only the compilation phase, not the test phase. So that's really, really, really annoying. The variability increasing like that is very strange. So technically, we focused on 2 different aspects. One is like the no-op build. So how fast can you be when there is literally no change?
Can I quickly interrupt you? There was a question on that last graph, if you don't mind hopping back to it. What does the y-axis represent?
Yeah, please.
It's the number of builds that are it's kind of like a histogram, right? It's basically the number of builds that took that time. So take like the 5th minute, right? So you basically have like 100 something builds that actually like fall in that category. That makes
Gotcha.
sense.
There's also someone else helping in chat. And then this is pretty deterministic. This isn't like an outlier of that one 5.5 hour build. That's consistently on the long end.
It is not. It is an outlier, but I think it's kind of like there is no guarantee on like where you fall in this list, right? Because Bazel seems to have like a longer tail than like CMake, and you don't see like a lot of red dots kind of like after the main like 1.5 hour section for CMake, for at least it is right now.
Gotcha. All right, thank you.
So one approach to reduce build time that we took is like focus on the no upgrade. So what do you do when you know that there is nothing has changed, or you resubmit the same PR and it should be as fast as possible. Right. And then it allows you to find a lot of issues because you know that nothing needs to build. So whenever something builds, it's an error or it's something that is misconfigured, or there is some reason to discover that makes the build happen when it shouldn't. So of course we found a lot of issues like files that changed and we didn't want, or environment variables or anything, and that's perfectly valid reasons for Bazel to recompile, but we didn't want that to happen, so we fixed them. And then we discovered that like the evaluation time is quite significant, from like 2 to 3 minutes when we start from a called Bazel invocation. So we decided to persist the Bazel daemon, the Bazel server on CI, which is dangerous, but gave us this like 2 to 3 minutes speed improvement. Checking out the source tree was also slow, so we decided to persist the source tree. That's also dangerous. We don't start with the clean state. We try to clean the source tree, of course, between 2 builds, but we still keep it locally. And that's combined with the Bazel server running allows us to use watchfs to watch the changes, so Bazel can know immediately what file have changed when it starts building and doesn't need to scan the build, which also takes a lot of time. And then we are playing with very advanced flags, like trying to increase the number of cached digests in Bazel daemon so that it can actually keep a digest for each and every input file, and does not need to recompile like to hash any source file because like they were evicted from cache. That manages to bring down the whole build like without test, because obviously there is no test because it's an old build, so we don't need to run the test. But we went from 15 minutes to 3 minutes, so that's a crazy job, a nice win, and a very pleasing result. Sadly, the situation is not that good for the average builds, like the other builds, because they get slow, try to download from the cache. We have very large artifacts and very large stuff that needs to be downloaded. So whenever one of these things stalls, and we have observed like download stalling for, what was it? Hours, yeah. So sometimes it takes like downloading for 1 hour and it doesn't make any sense. So there are probably network issues that we need to understand in infrastructure. We also try to remove some things from the cache. When something is that big, then we decided that we don't want to cache it, and it's faster to build locally. So we can just say, don't build it, don't upload it to the cache, and don't download it from the cache. And we also went for like the build without the bytes, but that's where problems arise, because we try to download only like the top level artifacts that we need and nothing else. That reduces the network bandwidth, of course. We download way less stuff, but yeah, because files are not really present on the disk, Bazel tends to rebuild something sometimes for strange reasons that we may explore later. So we decided to tell Bazel not to check the output files. And so Bazel is like, okay, the output file is missing, but you asked me not to check for it, so I'm perfectly fine with this action is still up to date, right? Except that then some output files are missing, and we're kind of creating a loop of bugs that we need to disable this entire set of features, because just because it doesn't
So
work.
quick question related to this slide. Could the network slowdowns be fixed by checking the dependency sources into source control?
The network slow is like when we really download something from the cache because we need it. So that's a perfectly valid usage of the cache, and that's the intended thing. But for some reason, I mean, there are so many different things that can interfere. There are like maybe Bazel is like should detect that the connection is down and keeps it open so it doesn't retry when it should, or maybe it's like some intermediate node in the network that doesn't properly cut the connection. It's like we have already debugged some of these, but apparently that still happens.
That's interesting. I'm curious if anyone, maybe today, but these streams tend to be watched, the recordings a lot more than live. So in the next couple of days, as people catch up on this, I'll be curious if anyone reaches out to you in Slack over any of that kind of networking issues. Nicholas just said, yeah, he understands there, but keep an ear out in Slack. You can find Guillaume on our Slack channel if you have any ideas on that networking thing. That I mean, debugging infra issues, you probably can't help particularly in that one, but anything that comes up, by all means, reach out to him.
Right. Yeah, that would be great. Let's see. So what we are doing here is a bit dangerous. Like we have kind of trading correctness for speed. Well, not exactly, right? But we are like stressing Bazel to its limits because we are going for like fully stateful model where we keep the same checkout, we keep the same Bazel process running, and then we want it to be as fast and still correct as possible. And so we are seeing all of the issues because in that setup, if Bazel is a bit slow, that's probably like an issue with Bazel or the way it's implemented or like something we need to improve on. And if there is any correctness issue, then there is no CI to care for it, right? Because everything is like stateful. So it's not as if we start from a clean CI and we are sure that there cannot be interference from the previous build. We know that there are all the possible reasons to have interference from previous builds. So we need to trust Bazel, and Bazel needs to be perfect in that setup. And it's not always the case, at least for speed, and correctness is, needs to be very careful, technically. I wanted to explore another and maybe last main topic here, which is this is about users in the end. So of course we are like developing and hacking on our side on our own, but at some point this needs to be deployed and needs to be adopted by developers into the team. So this is a process that started developers are onboarded and they get like explained the new build system about like 10 a week. They're mostly curious. They want to use the new build system. They want to play with that novel thing. But soon it appears that their workflow is broken or really changed. Sometimes there is no way to do what they used to do because we had no idea this was a thing in the old build system. So we need to be really responsive to answer for CI failures because it blocks them on the current work. Also answer questions on Slack, make the improvements that they need. And it's like 7 people team is not that big if you need to also be always available for all of these issues. But mostly users are really happy with the change. That also brings a lot of design issues for how do you use Bazel and how do you explain how Bazel is used. So we had, for example, this question about how to configure the targets. When you build an image, it's fairly easy to transition to the right board because an image is built for one board and that's it. But when you build an application, then it's more complex because applications are built for several boards. So either you provide the right default for the users, but sometimes it's not what they want. So how do you handle that? Do you build for all of the different supported configurations? That's feasible because Bazel caches many things, so it can be envisioned, but it's not perfect. And on the other side, you can ask them to provide the configuration that they are targeting, but then we get back to the issue mentioned before that we need to generate huge Bazel RC files with all of the possible configurations and agree on the different names. So it's not that trivial. Another issue that we had is that it's not easy to escape Bazel in different ways. So we generate build. We build an image, but that image contains application, and these applications still have reference to the Bazel paths in their R path. So they are depending on like the location that Bazel used for the libraries. That doesn't work because we don't really deploy things with the same layout as Bazel run files on the boards. That needs to be fixed. Interestingly, that's the same issue with Nix. Nix also includes like parts specific to Nix, and we don't really want or need to use on the boards. So we want to escape both Bazel and Nix at the end of the build, and that turns out to be sometimes difficult. So users will see errors referring to paths that are not valid on the boards because they're just like Nix and Bazel paths that are left over. More generally, like Bazel builds everything in its own environment with like the run files and all of the symlinks. But if you want to mimic the run environment of Bazel for a Docker image, for example, to run an application somewhere else, then you need to mimic all of the run files tree. That's also complex. Not mentioning that creating all of these run files is pretty slow when you get to huge dependency trees. So yeah, escaping Bazel is not as easy as someone expects. And yeah, I mean, Bazel leaks into the workflow of all of the developers. Like they used to run the virtual environment and then some comments in there. Now they need to learn how to Bazel run, then the proper label to the virtual environment run file, and then they can only send the comments. Well, of course, we can make it a bit shorter, like create a top-level alias for it, and then work for it. We could eventually envision to make like the wrapper script to hit Bazel run behind the scenes so that they can still use the ./virtualenv API, but we are stuck right now because, I mean, that tool cannot decide if it has to hit CMake or Bazel. So we can't really reuse the old API, the old script for the new Bazel build system. There are also some interesting issues, like before you could start the virtual environment and then run some other CI commands. But with Bazel, you can only have one Bazel instance at a time. So you cannot run two Bazel run commands in parallel, or even building while you have like a virtual environment running for you. So that's something we have to work around. And yeah, before you could just hit some binary that was present on disk and you knew that it was inside the tree. Now Bazel builds everything outside of the tree, which is nice for correctness and like keeping everything isolated. But it's more complex because either you need to use Bazel bin, but Bazel bin is not provided because we have different target platforms, so that would be ambiguous. It's removed. Bazel out, you can hit. It's sometimes difficult to discover, but at least that's stable. It's just that sometimes it disappears. If you build a different set of targets, then your old binary is not there anymore in these symlinks. And then you can go for the cache entry, but that does not update with the build. So it's pretty dangerous to use an old one that doesn't match your current build. No real answers for that. I think it's something we can Bazel can improve or that can be worked around. But then again, right, it's just like escaping Bazel. It's not that easy.
So real quick time check. We're just about at time. I will give you a couple minutes to wrap it up. There are a couple things going on in chat right now, which are kind of interesting. I'd ask those of you in chat, especially Mark, with your comments about escaping, actually just quite the conversation going on, that Nikhil is part of. Never mind, you're actually seeing it as well. So I was going to say take it to Slack to make sure that it was being seen. This is one of the reasons why you came along, to keep an eye on that. So cool. By all means, Guillaume, finish things up.
Okay, right. So yeah, I think I will just skip this design question there because there are more interesting things that we need to skip over. But yeah, we have this issue of like trying to build everything, which is not trivial. Just a quick note about remote execution. It's something that we've explored, but is not installed and deployed yet. So because we have lots of issues, and when we add remote execution, it's unclear if like the issue comes from remote execution or from something else. So it was a nightmare to debug. So we just decided like build is not stable enough to enable remote execution right now. It's also a bit more complex because of Nix, but I have a talk that describes that. Some of you may have seen. And it requires infrastructure and more people, so like not the right time for that now. But yeah, in theory, we could gain much from this remote execution, and our tests show that it's not that simple right now, because I mean, for an incremental builds, everything is, you just need to rebuild the spine of a build. So that's sequential anyway. So we're like distributing the build is not that important. And we cannot really distribute tests now for two reasons. One, they're like huge binaries that we need to send to another machine. So that takes a lot of time and then that kind of kills the performance. And also because tests are still monolithic. So remote execution is something that would help, but we need more work to make it really, really useful. So back to the first slide, kind of sandboxing, that's something we could bring in thanks to Bazel. Reproducibility, maintainability too, like we can easily read Bazel code. It's not easy to write so, but every time, but we can navigate that. Speed is kind of on hold. Of course, like build times are a bit faster, but it doesn't change drastically the overall 4 hours that are also due to tests. Remote execution may help, but that's unclear. Reproducibility doesn't really change much. Like it was working apparently okay with the old CMake thing. And caching, as we have seen, like the fact that Bazel can be totally incremental bring us, I don't know on average how much it is, but you see that the old CMake was 40 minutes, like no less than 40 minutes. And with Bazel, you can go to less than 5. So that's a gain that we have with Bazel. Remote execution is like on schedule, and we can say much more about that right now. So yeah, reworking everything, that's good because you go through everything, you ensure that the build still makes sense, you remove all cruft, and like a rewrite is a good thing for build system, even if it's costly. But we had to fight so much for some of like these obvious results, having Bazel to perform faster than CMake, having Bazel to be correct, and like fixing our actions to be correct with Bazel. Yeah, so at this stage, it's kind of, well, I'm not sure if we gained much. We have still ideas to improve it, so it's not done, right? There are plenty of ideas to make it better, but there is a lot of pressure right now about like, is it worth the investment? Because that's a company that has to make kind of benefits. We already invested. Honestly, Intuitive invested a lot of money into that project, and yeah, overall, I think we can summarize that with saying that it's still an exciting adventure, but gains are like not as obvious and like as easy to come by as we had expected when we started. Mandatory meme.
Of course. I'm very happy into it that. Actually, if you want to go back to that last slide real quick, as much as I love the Boromir meme, I'm super glad we had this opportunity. One of the things that, you know, this channel, the idea of the streams, it was meant to be partially technical in nature, us being able to talk about things that are getting worked on that you'll see in the future, roadmapping in nature. But these kind of use cases are very, very difficult to reproduce internally. We don't have this giant code base. We don't have robots. We might probably have robots somewhere in Google, but you get what I'm saying here. All of these kind of board concerns, the different architectures, this is all stuff that with taking no shot at the Bazel team at all, just are not currently on mind. So getting this opportunity to see that, yeah, there are some really wild, wacky cases out there that are working, but because of certain decisions take a little bit of hacking, I think is phenomenal. I'm super glad that we have this opportunity to hear from you. I'm super glad that you two took the time to speak with me today. I know that you were prepping this quite a bit, and I do thank you for it very much. So that's about it for this week. The next time the next time most of you see me will be at BazelCon, either virtually or in person. Feel free to come up and say hi. I'd love to meet all of you. Otherwise, thank you, Nikhil. Thank you, Guillaume. I am Jason, and we will be back on these streams in December. Take care, everyone.
Thank you, Jason.
There we go. Thank you, man.